Hey guys, welcome back to JAMB Physics Class. Now let's focus our attention on what area expansivity. So in this video here, we're going to talk about what is area expansivity, then the formula in calculating area expansivity. So when I'll be giving a static question here, the formula you're going to use to calculate what area expansivity, then we're going to define each of the 10 in the word area expansivity formula. Then after that, we're going to solve like 3 to 4 questions under area expansivity. So you'll be able to know how to solve problem or calculation when it comes to area expansivity. After that, I will give you your assignments you are going to take home. You understand? So what you want to do here is make sure you have your pen and notebook so that you can take part in this class here. So what is area expansivity? Area expansivity or superficial expansivity of a substance is defined as the fractional increase in area of a piece of that substance per degree raised in temperature. Do you understand? So the fractional increase in area per degree raised per degree raised temperature of that substance is called area expansivity. Now the symbol is what is better. I get is what is better. That is symbol. So when talk about area expansivity, beta here is what change in area over what the initial the original area times change in what is temperature. Do you understand? So now let's define solution here. So if you have change in what A is equal to what is what final area minus what the original what area or initial what area. You see that? Then change in the temperature go to be what final temperature minus what the initial what temperature. Do you see that? Now this one here B is the what area expansivity. Area expansivity. Now it can be what per degree or per Kelvin. Do you understand? Now, if for example here the area expansivity is given in per degree, what you want to understand here is that you know what this temperature should be what in degree Celsius. Do you understand? But if it's given what in per Kelvin, you have to convert what this one here to Kelvin. Now, this area can be either millimeter square, centimeter square, or what meter square, depending on the one you are given. You understand? Now, that you want to understand here is that the area expansivity is equal to 2 times linear expansivity. Just that it's called linear expansivity. If you know that you have not watched my test video when it comes to what linear expansivity here, please check out my complete video. You understand? It will be at the description below, or it will be at the first comment section. Go and watch that one here because it's the first topic before this area expansivity. For this area expansivity, we still have cubic expansivity. Do you understand? So these are the things you need to know when it comes to area expansivity. So we are going to look at some questions now. Here we have our first set of questions. So question 1: a metal sheet of area 100 cm3 was heated through 70 degrees centigrade. Now, mind this word through 70 degrees centigrade. It means that it is the increase in temperature. That is going to be change in temperature. Just please understand this kind of question here. Calculate its new area if the linear expansivity is 0.00017 per Kelvin. So now let's tackle this question here. So that is this 100 cm3 here going to be my A1. So my A1, that is my original area is 100 degree or 100 cm3. Now they say it is heated through, so this is not my initial temperature, this is not my final temperature here. It is what is change in temperature. Do you understand? So that is change in temperature is equal to 70 degree centigrade. Do you see that? As easy as that. So this is will calculate the new area. Just now, you should calculate the new area when they give us linear expansivity. So the linear expansivity is 0.00017 per Kelvin. Very important. Just so I want to they say show I want to calculate this one here? How do we calculate this one here? It's very easy. Remember, my area expansivity is equal to what? Change in area over what? The original area times change in temperature. Do you see that? Now remember, change in area, like change in area is equal to what? A2 minus A1. So we can say beta equals to what? A2 minus what? A1 over what? A1 times change in temperature. Now, here I already know what my change in temperature. I already know my what A1. Just that. Now, but there's one thing here you want to do here. This 70 degrees centigrade, you have to convert to Kelvin. Now, this is the reason why you have to convert to Kelvin, because here is Kelvin. So how do you convert to Kelvin? By adding what? 273. So 70 plus 273. What are you going to get? Here we have 343 watts Kelvin. Do you understand? As me here is per degree centigrade here, so there's no point. But since here is per Kelvin, you have to what? Make it to be uniform. Do you understand? In some table they leave it like that, because in some table it is be left like that, but you still get the same answer. So now, yeah, we know this one. We know this one here. Now, this is what they say should look for, right? Now, they did not give me this one here. Rather, they gave me this one here. This way, I've now used beta equals to 2 times linear expansivity. You understand? So the relation between area expansivity and linear expansivity is what is this. So we're going to give you what? Beta here equals to what? 2 times 0.000017 per Kelvin. So if you check it very well, here we have 2 times 0.000017. So here we have 3.4 exponential what? Minus 5 per Kelvin. This is that. So I'll just write this place at. I will just write for at here. Then place we want to find area expansivity, which is going to be 3.4 exponential what? Minus 5 per Kelvin. This is that. So from there now, what I'm going to do here, let me know why it is here. I will make A to the subject of formula. This is that. I will make A to the subject formula here. So if I should cross multiply, I will say A2 over what? A1 equals to what? Beta, which is what? Area expansivity times the original area times change in what? In temperature, which is what? Increase in what? In temperature, right? Now what I want to do, I'm going to calculate all of this one down here. So it's going to be A2 equals to what? A1 plus beta times A1 times this, that. So what I'm going to do now, I'm going to substitute my values. So it's going to be A2 here equals to what? My A1, what is my A1? 100 plus. So let's just be in bracket here. Beta is what? Is 3.4 exponential what? Minus 5 times. My A1 is what? Is 100 times. Increase in temperature is what? Is 343. This is that. So it's going to be 100 plus 3.4 exponential minus 5 times 100 times 343. So you have 101.17. What is the unit? Unit is what? Is cm3. This that. So that is the answer to this what question, as easy as that. Do you understand? Now I want to pause this video here and try this one for me. Do you understand? I want to see what you can do here. Pause the video and see how you can solve this question for me. Just do it now and leave it at the comment section. Now, please, if you are my students, if you are my JAMB students, please let's always communicate through the comment section. It's very important to interact in this class. Just so because these are, I guess, to know you more. There's a place that only watch this video and just go like that. Please don't be like that kind of student. And if there's any topic in physics, math, and chemistry that is giving you headache here, please only give suggestion at the comment section, because I create video based on my own findings and the rest. So I'm not be creating video based on your own, like the topic that is giving you issue here. So let's always communicate the comment section here. Any topic that is giving you headache, or if you want us to design the class in a way that will suit you, is very important also here for me. Just because the main reason why I'm creating this video, why this YouTube channel here is for you guys, not for myself, for you guys, something to be of part is for me to be part of your own success. Do you understand? If you watch this video and you score like 280 in your JAMB examination, then you still come to the comment section that my video help you a lot. Do you understand? So don't just watch video here and just go like that. Always interact at the comment section. So please go ahead, solve this question and leave it to what at the comment section. So now this question here is exactly the kind of question we have already solved. Do you understand? So but leave your answer in the comment section. So let's solve it together. Let's solve the question together. See that the area of a square meter is 600 millimeter what square. Calculate the new area when temperature is raised by what 15 Kelvin. So it's very easy here. My A1 is equal to what 600 what millimeter what square, right? 600 millimeter square. What they're asking us to calculate is what is A2. Very easy, A2, right? Now change the temperature, which what change the temperature is already equals to what 15 watts Kelvin, right? Now my area expansivity is what my linear expansivity is 1.9 exponential what minus 5 per what Kelvin, right? From here now, let me get what my linear expansivity is this. So for here, let me give my area expansivity, which is what beta equals to 2 times this one here 1.9 exponential minus 5, right, per Kelvin. So what will be the answer? So you have 2 times 1.9 exponential minus 5. Here we have 3.8 exponential what minus 5 per Kelvin. This is that. Remember, we are remember beta equals to what A2 minus what A1 over what A1 times change in temperature. If you what make this guy solve it a formula here, which I've already done, it's going to be what A2 equals to what A1 plus beta times A1 times what change in what temperature, right? So let us impute our values here. A2 equals to what? My A1 is what is 600. Let's ignore the unit first. Plus my beta. What is my beta? My beta is what is 3.8 exponential what minus 5 times my A1 is what is 600. Then my change in temperature is what is 15. Can you see that? So let's use our calculator to get our answer here. 600 plus 3.8 exponential minus 5 times 600 times 15. So you have 600.34. So here we have A equals to what 600.342 millimeter what square. That is the answer. As easy as that, right? It's very easy. So let's see how we can solve like 2 more questions before we end this class. So here we have these 2 questions here. I'm going to solve them. You understand? Now, please, if you know that you are not part of our general group or private group here, where I teach students one-on-one every single day, right? Please make sure you join the online class. Do you understand? Like what I said, I have general group chat and I have what the private class. Do you understand? So if you're not in any of these groups, please leave that comment section that you want to be part of the group, or you chat me up through WhatsApp, right? The number will be displayed on the screen here, so I can be added to what the group chat. From there, now you can ask me questions. Yes, so we can interact. Now let's look at what the third question is. That an iron plate has an initial area of 200 cm cube at 25 degrees centigrade. When heated to 22.5 degrees centigrade, the area increased by 0.24 cm cube. Calculate the coefficient of area expansivity of the plate. It's very easy here. So my A1, here is what my A1. My A1 is what is 200 cm cube, right? My initial temperature or original temperature is what 25 degree centigrade. Yeah, there's no point of converting to Kelvin. Do you understand? Because the area expansivity will be what in per degree centigrade. Do you understand? So now my T2, now my final Now my final what? My final temperature, which one is theta 2 is equals to what? 225 degree what centigrade, right? Now there's like the area increased by. Do you understand? This is not the second area. This is what increase in area. Do you understand? Increase in what area? Change in what area? So the change in area is what? 0.24 cm cube. So change in area, change in what in area is equal to what? 0.25 cm cube. Do you see that? What they say she calculate? They say she will calculate uh area expansivity. This is what they say she will calculate. Area expansivity is very easy. Remember, area expansivity equals to what? Change what in area or what? Original area times change what in temperature. And that change in temperature is what is theta 2 about minus what theta what 1. Do you see that? So what I want to do here is what substitute your values here. So my change area is what is 0.25 centimeter over what? My initial area, original area is what? 200 cm cube. Square, right? Square. It's not cube, it's square. Sorry, square should be square. It should be square. There's a mistake here. Everything should be square, not cube. It should be square. Do you understand? It should be square. There's a mistake. So here we have square. Square. You see that? Square. So here we're going to be final, which what? 225 minus what? 25. You see that? So this we cancel out this one here. What will be left? We use our calculator to do it here. Here we have, so here we have this one here. 0.25 over what? 200 times. Here we have 225 minus 25. Here we have 200, right? So going to be 0.25 divided by 200 times 200. Here we have 6.25 exponential what? Minus 6. What is the unit per degree centigrade? Do you understand? So this is the what is the answer. So now if I change that to what? To 150 cm square, and here we have, let's leave it like this. Here we have 300 degrees centigrade here, and there's an increase. Here we have 0.45 cm square. So go ahead and do something for me. Go ahead and try this one and do this one for me. So go ahead and solve this for me. So this is now your what assignment. So if you enjoy this class here, please do like, make sure that this video is helpful. If you are not subscribed to the channel, please kindly hit the subscribe button and like this video so that this video can get to other person here. Please, if you know anyone that's supposed to watch this video here or going for JAMB tutorial, like is going for, he or she is going to write the upcoming JAMB examination, please kindly share this video to them so that they too can be part of this class. Just refer Tempris TV to other people so that this channel can grow and can spread to other persons. Thanks for watching. If you have not watched the video on linear expansivity, check out the video on what linear expansivity. See you in my next class.